Let's take a look at factoring quadratic trinomials. A trinomial itself is an expression with three terms. A quadratic trinomial is an expression with three terms. We have an x squared term, an x term, and a constant term. Some quadratic trinomials can be factored, some cannot. And the rule for this is b squared minus 4ac, is it a perfect square? Because of whatever value this is here, if we take the square root of b squared minus 4ac, if it gives us an integer that's positive, then indeed this quadratic trinomial can be factored. A, which is this a here, b, which is a coefficient of x, is this, and c is just their constant. What we're going to do is we're going to take a look at example 19 and use these values here to plug in and see if that particular trinomial, 6x squared plus x minus 12, is indeed factorable. So in this case, 6 is our a, 1 is our b, and minus 12 is our c. So let's take a look at what is the square root then of b squared, which is 1 squared, minus 4 times 6 times minus 12. When we do this, we're going to get square root of 1 plus 288, which is equal to the square root of 289, which is equal to 17. So since this is a positive integer, this particular trinomial can indeed be factored. Let's look at trinomials that are very simple with a leading coefficient of 1, such as x squared plus something x plus ab. And the way we get this is we have a factor of x times x, which is our x squared. We have outside, which is bx. We have inside, which is ax, and finally last, which is our ab. Now what we want to do is take a trinomial like this and factor it. And the whole trick to this is taking a look at the constant here, which is 15. Let's write down all the factors of 15. So 15's factors are 1, 3, and 5. Those are the three factors. Now out of these, we have to have something that's going to add to 8 and something that's going to multiply to 15. Well, 3 and 5 fit that because 3 plus 5 is definitely equal to 8, and 3 times 5 is equal to 15. And that's why we can very easily say that x plus 5 plus x plus 3 is our solution to factoring this particular equation here. Now let's take a look at this particular expression and see how we would factor that, not knowing what the factors are. Again, we're going to take our constant, which is 8, and write down all the factors, which is 1, 2, and 4. And what we need to have out of these factors is something that adds to 6. So 2, positive 2 plus 4 equals 6. And we also have something that has to multiply 2 times 4 to get 8. So this is going to give us positive 2 and positive 4. So that's why it's x plus 4, x plus 2 to give us a solution for the factoring of x squared plus 6x plus 8. Let's take a look at this one, which is very similar. Again, we still have factors of 1, 2, and 4 for 8. But this time we have to combine them so we get minus 6. So minus 2 minus 4 gives us minus 6. That works. And then minus 2 times minus 4 does indeed give us 8. And that's why our solution is x minus 4, x minus 2 as the factors of x squared minus 6x plus 8. In our last example here, we have again 8. So that's 1, 2, and 4. But we need to have two things that add together to get minus 2. 2, 4. How do we get minus 2? Well, that's 2 minus 4 will definitely give us minus 2. And 2 times minus 4 is going to give us minus 8. So that's why we have x minus 4 times x plus 2 as the factors of x squared minus 2x minus 8. Let's take a look at factoring this particular expression here. Again, we're going to take our constant 15, and we're going to write down the factors of 1, 3, and 5. Now what we need is something that's going to give us 2. So 5 subtract 3 is 2. And we also need something that's going to give us minus 15. So 5 times minus 3 is minus 15. So when we put these into our factor here, it's going to be x minus 3 times x plus 5. And let's take a look at that's x squared. Outside is going to be plus 5x. Inside here is going to be minus 3x. And if we do the outside terms, this is minus 3 times that, which is minus 15. This is going to give us x squared plus 2x minus 15 and we can see that these are the factors minus 3 and plus 5. Now example 24 has 2x cubed plus 4x squared minus 30x, and if we take out a common factor of 2x, we can find a polynomial here with a 1 as our coefficient. And again, we take the 15 and write the factors of 15, 1, 3, and 5, and we have to have something that gives us 2, which is 5, subtract 3, and we have to have something that gives us minus 15, which is 5 times minus 3. So that's why we have x minus 3 here and x plus 5 here, and that is our final solution here. Sometimes you're asked to factor trinomials that have more than one variable, such as this one here, where we're asked to factor x squared plus 5xy plus 6y squared. Now a trick that you can use is temporarily just get rid of everything in y, and what you'll end up with is this equation. Now the factors of 6 are 1, 2, and 3. I think you can see that 2 plus 3 is going to give you the 5, and 2 times 3 is going to give you the 6. So that's why we have this factored as this. Now if we take x plus 2 and add the y back, and x plus 3 and add a y back here, if we do the first terms here, that's x squared. Do the outside terms here, that's going to be plus 3xy. If we add the inner terms, that's plus 2xy, and we add the final term here, which is 6y squared. This is going to give us x squared plus 5xy plus 6y squared, which is our original. So this is indeed going to be what we need here as a solution. So this is actually the factor of x squared plus 5xy plus 6y squared. Let's try to factor this particular expression here. And what we're going to do is we're going to get rid of everything that's not an x squared, an x, or a constant. So let's get rid of the w squared, the wy here, and the y squared, and we're going to end up with this as our expression. Now the 4 as a constant has factors of 1, 2, and 4. Now we have to something that's going to add or subtract to give us a 3. So let's try 4 minus 1. And we have to have something that's going to give us negative 4, which is 4 times negative 1. So this is going to give us 3, this is going to give us minus 4, and that's what we want. And that's why we have it factored this way here. So let's notice that the w is in front of the x. So we'll make this wx minus y here, wx plus 4y here. Now let's see what happens when we expand this out. Wx times wx is going to give us wx squared. 4wxy minus wxy, that's going to give us our positive 3wxy. And finally, minus y times 4y is going to give us our minus 4y squared. So that means that this factor, when expanded, will give us our other expression back. So this is the factor of w squared x squared plus 3wxy minus 4y squared. Let's take a look at factoring an expression that's at a higher order power. Now don't forget that x to the 6 is equal to x to the 3 to the second power, because 3 times 2 is indeed 6. To simplify this even more, let's take an intermediate step of putting in w equals x cubed. So if we take a look at x to the 6, which is just x to the 3 squared, that would be w squared, would be this term here. Minus x cubed here would be just minus w. And finally we get the negative 6. Now if you remember, 6 itself has factors 1, 2, 3, and 6. We need something that's going to add to negative 1, so 2 subtract 3 is negative 1. It also has to multiply to give minus 6. 2 times minus 3 is minus 6. And so I think you can see the factor is going to be w minus 3 times w plus 2. And if we substitute back in for w, x cubed, then we're going to get this expression here. Let's validate that that is correct. So this is x cubed times x cubed, which is x to the 6. This is the outer one here is plus 2x cubed minus 3x cubed minus 6, which will give us x to the 6 minus x cubed minus 6. And so therefore this is the factor of this original expression here. Let's look and see how we would factor this expression. X to the 2n, if you recall, is x to the n squared. So let's let an intermediate variable, such as w, equal x to the n. Then this expression here will translate to w squared plus 5w plus 6. And if you remember the factors of 6, you'll find that we have to have something that's going to add to 5, and that's 2 plus 3. And we need something that's going to multiply to give us 6, which is 2 times 3 to give us this term here. So if we do that, we can validate that when we expand it back, we're going to get exactly the same expression as we had before. If we now substitute w equals x to the n back in, we're going to have x to the n plus 3 times x to the n plus 2. And if we want to validate that, this is x to the n times x to the n, which is x to the 2n. We have x to the n times 2, which is plus 3x to the n, which gives us our 5x to the n here. And we finally have 3 times 2, which is going to give us our plus 6. So we can see that this is the factor of this particular expression. Let's see if we can factor this expression here. First thing that you have to realize is x to the 6n is really x to the 3n squared. So let's let w, an intermediate variable, equal x to the 3n. Then I think you can see that w squared will be this term here, and 2w will be this term here, and finally minus 3 we just have here. Once we've seen that this is our expression in a simplified form, we can look at factors of 3, which are 1 and 3. So 3 subtract 1 is 2, 3 times minus 1 is 3. So this is going to be w minus 1 times w plus 3. Now at this point, let's substitute for w x to the 3n. So this would be x to the 3n minus 1, x to the 3n plus 3. So when we simplify terms, we get back exactly what we had up here, our original equation, which means that this indeed is this expression in its factored form. Let's see how we go about factoring this expression. Now if we let w equal x plus y, I think you'll find that we can convert this into this simplified expression here. And what we need is factors of 30, and here's all our factors of 30, but notice we have a negative here, so we need some sort of subtraction. So I think you'll find that, 5 plus 2 would have worked, but we need a subtraction, so it's going to be 10 minus 3. So 10 minus 3 gives you 7. 10 times minus 3 gives us minus 30. So this is going to give us this factoring here, w plus 10 times w minus 3. Now all we have to do, and I think you can validate that w times w is w squared, minus 3w plus 10w, 7w minus 30, that all works. So if we substitute in now this value here for w, we're going to end up with x plus y plus 10, x plus y minus 3, and we can remove these brackets because these are additions, so our final expression that we have for the factor will be x plus y plus 10 times x plus y minus 3.